Let's solve this physics problem about a ship moving along the equator. A ship moves along the equator to the east with velocity v0 equals 30 kilometers per hour. The southeastern wind blows at an angle phi equals 60 degrees to the equator with velocity v equals 15 kilometers per hour. We need to find the wind velocity v prime relative to the ship and the angle phi prime between the equator and the wind direction in the reference frame fixed to the ship. Let's start by setting up our coordinate system. We'll define the east direction as our positive x-axis and the north direction as our positive y-axis. To solve this problem, we'll use vector subtraction to find the relative velocity. The relative wind velocity equals the wind velocity minus the ship's velocity. Let's first determine the ship's velocity. The ship is moving directly east at 30 kilometers per hour. So its velocity vector is v ship equals 30, 0 kilometers per hour. Next, let's determine the wind velocity. The wind is blowing from the southeast at an angle of 60 degrees to the equator with a speed of 15 kilometers per hour. To find the components, we use v times cosine of 60 degrees for the x component, which equals 7.5 kilometers per hour. And we use negative v times sine of 60 degrees for the y component, which equals negative 12.99 kilometers per hour. So the wind velocity vector is 7.5, negative 12.99 kilometers per hour. Now, let's calculate the relative velocity of the wind with respect to the ship. This is found by subtracting the ship's velocity from the wind's velocity. The result is 7.5 minus 30, negative 12.99 minus 0, which equals negative 22.5, negative 12.99 kilometers per hour. So the relative wind velocity vector is negative 22.5, negative 12.99 kilometers per hour. Now, let's calculate the magnitude of the relative velocity. Using the Pythagorean theorem, we have v prime equals the square root of the sum of the squares of the components. That's the square root of negative 22.5 squared plus negative 12.99 squared, which equals the square root of 506.25 plus 168.74. This gives us approximately 26.0 kilometers per hour. Finally, let's calculate the angle phi prime. This is the angle between the relative wind direction and the negative x-axis in the ship's reference frame. Using trigonometry, phi prime equals the arctangent of the absolute value of the y component divided by the absolute value of the x component. That's the arctangent of 12.99 divided by 22.5, which is approximately 30 degrees. So the relative wind velocity is 26.0 kilometers per hour, directed 30 degrees below or south of the westward horizontal in the ship's frame. To summarize our solution, 1. We set up our coordinate system with east as the positive x-axis and north as the positive y-axis. 2. We found the ship's velocity vector, 30 kilometers per hour eastward. 3. We calculated the wind's velocity vector, 7.5 kilometers per hour east and 12.99 kilometers per hour south. 4. We determined the relative wind velocity by vector subtraction, negative 22.5 kilometers per hour east and negative 12.99 kilometers per hour north. 5. We found the magnitude of the relative velocity, 26.0 kilometers per hour. 6. Finally, we calculated the angle, 30 degrees below the western horizontal in the ship's frame.